See how I can control these motors and their direction just from my keyboard through signals from the microcontroller. You can do it too if you learn how to use the motor driver in the middle of it, the DRV8833. So let me teach you how to use it. Let's get right into this video. So hello guys, welcome back to my channel. So today we are going to be talking about the DRV8833 motor driver. So we are going to answer the questions: what is it, how do we use it. So topics that I will cover in this video is what it consists of. The pinout I will explain. That I have brought a whole lot of contents here, as you can see, which I made last night. So yeah, then I'm going to talk about some stats. Then I'm going to talk about the logic table of what input causes what function to take place. Then I will be giving couple of warnings. Then I will be showing how to control speed with it. Then I will be finally saying why the L298N or the L293D motor drivers takes an L. Very nice one. So let's get started with this video. So at the very first we need to talk about what the actual IC, which is this thing, consists of. So basically it consists of two H bridges. What is an H bridge? It is a very clever circuit which consists of 4 switches. As I have brought a diagram, as you can see here. So let's assume that this is a push button, this is a push button, and these are all push buttons. So this VCC is obviously a battery, and this ground is also a battery, and in the middle the DC motor is present. As you can see, it kind of looks like an it kind of looks like an H, so that's the name. But let's get talking about it. So when we supply current to a DC motor, it rotates, right? For example, this is plus, this is minus. When we change the poles, the motor spins in the other direction. So for example, if we say this is a DC motor and we supply plus here and minus there, so let's say it will move clockwise, right? Now if we change the poles, right, if we change the poles, change the orientation of in which direction the current is flowing, then the motor will turn anti-clockwise. That's very basic electronics. So let's assume that this is plus and this is minus, because this is ground, and this is VCC, right? So in that logic, when we let's say the current comes in both of these directions to reach to this ground. I'm going very basically. So let's say I'm pressing switch 1. So the current reaches here and it goes here, right? And then if we press switch 1, and if we press switch 4 too, then it reaches ground, and this is set to plus and this is set to minus, and let's say the motor turns clockwise. Then if we press switch 3, the VCC reaches here and it continues till here, and when we also press switch 2, it reaches ground. So the things are opposed, right, the poles, and it rotates anti-clockwise. So with this clever configuration of 4 switches, the motor direction can be controlled. That's very right. So what we need to do now is, obviously, to control this motor with a microcontroller like an Arduino, we can't make it press switches. We can, but that's not very efficient. So what we are going to do is we are going to replace these with transistors, okay, or MOSFET. So we can replace these with transistors or MOSFETs, right? Then For example, say this is a transistor and this is a wire coming out of the transistor. What they call it, I guess, I don't know, and I forgot. Which turns on, basically transistors are a digital switch, right? So to turn the motor clockwise, what we need to do then is the switch 1 transistor and the switch 4 transistors need to be activated. For the other configuration, switch 3 and switch 2 has to be activated. So basically this is the basic explanation of a H-bridge. So let's get back to our DRV8833. The DRV8833 consists of 2 H-bridges. So obviously one H-bridge can control one motor individually with individual commands, and thus 2 H-bridges can obviously control 2 motors with individual commands. Now you can wear 4 motors with 2 motor in place of 1 motor in parallel. You understand, right? I will show you a demo at the last of the video. I forgot to write that. So at the end of the video I am going to show you a demo, because I have made a circuit like this. Okay, so let's get back to it. So the H-bridge is what it consists of. Dual bridge, that's why you see that it is called dual bridge motor driver DRV8833, because 2 H-bridges is present. Now let's go to explaining the pinout. So guys, as you can see clearly, this is the pinout, and here why am I making this video? Because many people have explained how a DRV8833 module works and how to use it, but many of the modules have a different pin breakout, right? So for example, this one, the most common DRV8833 module consists of 12 pins, right? But this one consists of 16, as you can see, 8 on each side. So how to use this different breakout, because many people get confused by seeing so many pins here. So what are we going to do is explain the whole thing. Let's say I have 2 motors. This is a motor, this is the shaft, this is motor A, and let's say this is a motor B. This is its shaft. Very nice. Let me attach a fan to it, because why not? Very high quality fan, very high quality drawing. By the way, ignore the background noises, please. I really can't do much about it. So before explaining all the pins, let me cut out the obvious ones. So because many people get confused by seeing this NC. NC is nothing but not connected. N for not, C for not connected. So not connected. So we can rub out these ones because they don't matter to us. I am pretty sure they don't have any function. So also as you can see, we don't need so many grounds because there are 3 here. So one here, one here, one here. So let's get started. So first of all, let's explain this AO1, AO2, BO2, BO1. So the pin labeling consists of 2 motors too, like A and B. So these 2 control one motor, that is motor A as called, and one second, yeah. So these 2 control another motor which is called B, motor B. Similarly here, A in 2, A in 1, B in 1, B in 2. So these control the motor B, these control the motor A. So input will obviously be connected to Arduino Uno, but these outputs will be directly connected to the motors. Let's connect motor A, let's connect motor B. So the polarity can be attached by trial and error according to your needs. So maybe you need to connect the AO2 to the positive terminal or the negative terminal. That's whatever you want. But now let's come to the other pins. So basically, in summary, these are the motor pins that need to be connected, terminals, right? Now, say you have a battery. Say you have a battery. This is a battery pack of two 18650s. That is 3.7 into 2, 7.4 volts. So you need to connect this to because these will want these the batteries to connect to the motor to give power to the motors, right? Let's connect them here. So VM is basically VCC. You will have to connect it to the battery pack that you want control the motors. So basically the battery pack that you want to power the motor. How can I explain? Okay, you know what? Okay. So see, suppose you have a motor here, and in a car, right? In a car you have this motor connected to this wheel with a gearbox and all, and you want this to spin. So obviously maybe with a switch, sorry, switches are not like that. Yeah, so obviously with a switch you will connect it to a battery, right? What the hell? Oh, that feature that nobody wanted. I don't know why it is presenting. So for example, this can be a 7.4 volt, this can be 11.1 volt, this can be a 9 volt battery, etc. So that battery that you want to power the motor with will be connected here with VM and ground, right? So that is done. This VM pin is for connecting the battery, and the ground is common with these two. So now as we have completed this side, there is an interesting thing that I noticed in this motor driver. You can divide this into two parts, basically from the half. So this side is for the hardware part that you want to be controlled with. So the battery, you want to control its output to be filtered into the motors, not filtered, redirected into the motors. So, and in this side you can control. So basically this side you will have to connect with the car parts, and this side you will have to connect if you are making a car, that is. But let's say I am making a, because I am using this in the making of Diogo 3. If you have been following my channel, you would have noticed my making of Diogo 1 and Diogo 2. So I am making Diogo 3 with this driver. So yeah, I am taking an example of a car. So if you are making a car, then this side will be connected, this right side will be connected to your car hardware parts like the battery, motors, and this side will be connected to your microcontroller or single board computer, whatever, right? So now let's get on to the left side. This so firstly all of these pins are important except the not connected, obviously, but yeah, let's start with the ground. This ground has to be common with the Arduino or any microcontroller you are using ground, right? So you will have to connect it to the ground of the microcontroller you are using or the single board computer, whatever. That's done. That's very common in every motor driver. Now these input pins control the redirection and in which way do you want to rotate the motors, and I will show you how that works very soon with this logic table. So A/B in 1, A/B in 2, and what happens. So you don't need to worry about that, I will tell you that, okay, very soon. Basically you need to control it, connect it with in output pins in your Arduino, not analog ones, digital pins, right? So and if you can connect it to the PWM pins or the normal pins if you want speed control for smooth controlling and smooth stoppages, etc. You need to connect it to the PWM because PWM pins allow pulse width modulation outputs, and they can allow you to control the speed of the motors you want to run, right? So now I guess that's clear. And what signals do you have to send, high or low? I will tell you that in the logic table. But now let's get to the one of the most important and confusing pins, this STBY. STBY stands for standby. Many motor drivers don't have this, so people just ignore it, and they wonder why their motor driver is not working. But the truth is, this is a very important pin, and this has to be connected to a 5-volt source. I have connected this to a Arduino 5-volt, or most microcontrollers have a 5-volt pin, or you can just connect it with a normal pin and set it to high in code. This, by the way, this DRV8833 is compatible with both 5-volt and 3-volt logic. So you can use it with many microcontrollers, as many as you want. So, there is no restriction as such. But yeah, this standby has to set to high, because if you set it to low, it will the motor driver will go to standby mode and it will not work. So for the motor driver to work, you need to set it to standby. So that's all the pins explained. I will warn you about this standby pin again in the warning section. So yeah, Pinout explanation is complete. Now stats. There are not much stats that I can that are actually important. I will pair it up with the comparison with L series drivers, that is L298N and L293. Now let's get to the logic table, right? Yeah. So there are a total of 4 situations that you can get yourself in. Both in pins are set to 0, one is set to 1, and both are set to 1. By the way, in C embed logic, that is Arduino IDE, 0 means low and 1 means high. For example, in the second situation, in one of either A or B has to be set to not either. For example, let me talk about the A motor. Same thing will apply for the B motor. Okay. So that's the thing, right? Yeah. Now as we have taken the example of A, so in this scenario, A in 1 has to set to low, and A in 2 to be set to high. Yeah. So that's the thing. Now let's see what will happen in all of the scenarios. So 0 0, what happens? Both are set to low, so it will just do nothing. It will be stopped, right? No power will be supplied to the motors. Now with 0 1, it can either go forward or backward depending on which terminal is connected to which pin. But let's say this will move it forward. Then this third situation, when in 1 is set to 1 and in 2 is set to 0, then it will go backward. That is the opposite direction to these, right? These are oppositely related. And when 1 and 1 both input pins are set to 1, it will break. Now what is the difference between break and stop, and what the hell does break mean? Let me explain that. So for example, you are using a normal codeless motor, let's say, okay, and now these are the two output terminals, and when you just apply 0 0 to both, when the motor is first, let's say it's 1 0, and then you set it to 0 0, so then the motor will continue spinning, because of obviously friction is less, and because you have just set the voltage to 0, it will carry obviously the momentum and it will spin for a little while before obviously stopping. But if you directly set it to 1 that is brake, then what will happen? It will immediately stop. Why? Because the internal MOSFETs will connect both of these terminals. That will short out the current, I guess, right? Yeah, and then it will immediately stop. That's basically it. So let's take an analogy of a cycle. I don't know how to draw a cycle. So when you press the when you just stop paddling, that is, in this scenario you stop the voltage, it still obviously runs for a little while because it carries the momentum. Newton's first law, right? Newton's first law. Yeah, Newton's first law. And when you press the brakes, it immediately stops. That's what's happening in here. So that's the logic table, done. Because this is very simple. You just have to control 4 pins high low state. So that's why I will not even provide you the code, because the code is very simple. But if you request, I can obviously give, but I don't think you will need it. You are smarter than that. By the way, if you want, I can even send you this PDF. I don't know why you will need it though, but whatever. Couple of warnings I will say at last. This is last thing. Before demo, I mean, but yeah. So speed control. So the PWM signals. What is PWM? This is obviously PWM. High-low state is regulated like this with intervals in between, which simulates a lower voltage, even though the Arduino treats it as zeros and ones, because the zeros and ones are switching in between so much, so the mean voltage is taken like this. If it is a PWM cycle, the mean voltage in this whole time span is taken, so to average out a symbol voltage like this. So even though this is 1 and 0 and 0.5 can't really be expressed, it is still, the hardware is thinking it's supplying 0.5 because of this mean voltage, which is actually 0.5. So that's PWM, and by producing this type of signal to these input pins, you can regulate the speed control. This is I think special feature of the DRV8833. I have not really seen any more motor drivers which can be controlled, whose speed can be controlled with only 4 pins. So basically these input pins, for example 9 is a Arduino PWM pin in the digital section, but all of the pins in Arduino are not like that, right? So if you let's say connect it to 9 and send the PWM signal there, you can regulate the motor speed with that. So basically with PWM you can control the speed pulse width modulation. So speed control is done. Now let's compare it with the L298N. L298N is there, L293D is there. So both of these are similar, so I can compare it with this one. So let's first talk about the advantages of the DRV8833. Firstly, the DRV8833 uses MOSFETs, and this uses old versions of transistors. So the resistance is obviously low here, and heat produced is also low here, thus it's cool. But our resistance here is high, heat produced is also high, it's hot. So after this, the voltage drop here is 0.3 volt, but the voltage drop here is 35, sorry, not 35, my bad. It's 2 to 3 volts. So much of the power is lost. So we can say this one is efficient, this is non-efficient. Moving on, let's tell the disadvantages of the DRV8833. So firstly, this can only handle from 2.7 volt to 10.8, but this can handle up to 35 volts. That's the thing. Then there are two more. There is no heatsink in the DRV8833, but there is one in L298N. But I am not going to talk about that because still the DRV8833 is cooler because of what I said, usage of MOSFETs. But another thing which is really bad is that you have to power your Arduino microcontroller externally because it does not contain the DRV8833 a 5 volt output. But the L298N consists of one. So that's it, guys. I guess that's all. Oh yeah, another by honorable mention is this motor driver TB6612FN. This is also a good motor driver like the DRV8833. I just don't like these L series because they have annoyed me for a long time. So we have talked about this. Now a couple of warnings before we show you the demo. So let's talk about brakes first. The current needed to brake the motor, that is if we produce 1 here, then the current needed is very much, and thus the heat produced is also very much, so you can't spam it always. It's recommended to just do the basic 0 0, that is just stop voltage. Then some warnings are standby again must be set to high, not floating. Okay. And the second warning is you shouldn't overload it or else it will die slowly and without notification because it does not have a heatsink, and its voltage handling capability is low. So that's the thing, guys. Thanks for watching. So I will get back to you with the demo. It can play anytime now. So let's do this. So couple of warnings is also done. So thank you, guys. You will see the demo just now. For now, bye bye. So here I am, guys. This is the setup, as you can see. I'm going to show you the demo now. This is the main thing that we were talking about till now. This is the DRV8833. There are 4 motors here, but they are divided into 2 motors because as we talked about, we have to divide them into motor A, motor B. So this green wires that are connected to these 2 motors, these are motor A and these 2 are motor B connected with the yellow wire. So in the VM and ground pin we have connected the 9 volt battery because it is in the safe range of 2.7 volt to 10.8 volt. We are connecting the input pins to the digital pins of the Arduino Uno that has been connected to my computer with this code that allows me to control the whole thing with commands like FBS and IJK. So as you can see, as I said, stopping would require both to low, high, low, and if similarly in motor A, high, low, high, and low. So F will make this go forward, B will make this go backward, S will stop them, and similarly IJK for this, J will stop them. So I am going to replace this with a pi for Diogo 3. like I did with Diogo 2 with relays. So let's start it. As you can see guys, here in the terminal it's saying ready to control motors. Now I will be pressing F and pressing enter. Let's see what happens. So as you can see guys, this has turned on, and when I press B, the thing is reversed. As you can see, motor A forward, motor B backward, and now it's going backward. Now if I press S, as you can see guys, the motors have stopped when I pressed S. So now it's time for I. They go forward. K stop. Okay, so let's stop them. Motor B stop, and J. Oh, J was to stop, right? Sorry. K. So guys, for some reason the backward pin is loose, maybe. Yeah. So sorry guys for that. Things will just mess up. That's number one rule of engineering. So when I press K and I press enter, they go backward, and when I press I, and they go forward. When I press J, they stop. So now let's check the motor A part again. F forward, B backward, S stop. So that was the thing guys. 9 volt in VMGND. Motor A and motor B connected to BO, and inputs are connected to Arduino Uno, and most importantly the standby is connected to 5 volt, as you can see here, and the ground is common between this and that. Thank you for watching this whole video guys. That is the end. And yeah, now I'm going to my next task will be to replace the Uno with Pi. I will keep you updated if I can. Thank you. Bye bye.